Hey, today I'll take you behind the scenes of my game development journey. I made a small game project for my school assignment, and this is an extension of it. Learn new tools and pipelines in the process. I'm going to do a deep dive in this video into the methodologies I used, the challenges I faced, tools that I learned, and the progress I made with my game dev knowledge. This project took too long to complete, partly due to my inexperience and poor time management while trying to meet the deadline, but also because it's not easy making a game from start to finish. So let's start things off by talking about the tools that made this project possible. Many of these are the same tools that professionals use in the industry. You know, things like the engine, blueprint programming, Niagara system, material instances, input action mappings, just the usual stuff of a game project. The backbone of this project was
Unreal Engine 5.
Unreal is an absolute powerhouse of an engine. It supports features like dynamic lighting, real-time rendering, and the easy-to-use blueprint system. Most of Unreal Engine's hype comes from its lighting capabilities, and it's an engine catered towards having realistic 3D visuals and lighting. Paraphrasing Unreal Engine's documentation, the engine has its own visual scripting tool called Blueprints, which allows for rapid and more accessible development. It is a node-based system with code running from left to right. You use the nodes made by the engine, which range from basic operations like math, as well as the more complex ones, like a line trace node. It's efficient for prototyping, but less optimized than raw coding. Its code is built on C++, and you can implement scripts written in that language. I haven't done that myself since I have zero knowledge in C++. Unreal also has a node-based material editor, which allows for creating shaders and other complex materials. On the visual side, it has Nanite and Lumen for handling LODs, levels of detail, and real-time global illumination, which just means fancy lighting. There are also things like animation tools, correlation tools, and a marketplace with access to a wide range of pre-built plugins, tools, models, and other assets. Unreal Engine's got great scalability, supporting both indie projects as well as AAA productions. Renowned companies like CD Projekt Red and Halo Studios have transitioned to Unreal Engine 5 for flagship projects, citing its advanced features and robust performance. Like I said before, Unreal Engine has massive real-time rendering capabilities, creating insanely great visuals, which most studios nowadays really strive for. You know what else is massive? The number of studios that use advanced visuals as their marketing campaign for their games. Many of them show the graphics as a selling point, and unfortunately or not, it's working, and pretty much every large production has realistic graphics or something alike. However, the core problem of the graphics is how much those visuals tank your performance. Seriously, I had someone test it on a laptop, and it barely managed to run it. This is not only a barrier for players with worse hardware, it can also affect smaller dev teams and/or solo developers who want to use this engine. It's true that Unreal gives you the flexibility to cater and customize the look of your game, which lowers down the hardware requirements, but I think this shouldn't be something you have to tweak every time you open up a new project if you wish to have graphics that aren't realistic. I think for my future projects, I'd not use Unreal Engine because as good as the engine is, I'm not too interested in creating highly realistic visuals. I also want to finally branch out a bit more and learn how to program in a coding language. I think Unity would be a better choice for this as it's lightweight, great for learning programming, C#, which is much easier than C++, and isn't fully focused on realistic graphics. It's also widely used in the industry, pretty much on par with Unreal Engine. Moving on to the more nitty-gritty technical tools, one of the first ones I've used on this project was the landscaping tool. I used it to create the outdoors part of my level. Simple terrain, nothing too complicated. A quick read through the engine's documentation showed me how to get it working and how the landscaping tool works based on a texture mask. Basically, behind the scenes, the engine uses a black and white image to figure out the height of the terrain. Then from that information it creates a mesh and a collision, which you can add a material onto. It's a pretty good tool, easy to understand and easy to use. I managed to quickly create the landscape this way and add some icy mountains. Now, the only and the biggest problem I have with this tool is that you cannot remove the floor of the landscape. I had the icy mountains clipping with my terrain, very annoying. This was a big challenge for me and one of the first things I had to spend time fixing. I eventually figured out I had to export the entire Unreal Engine level as a FBX, because you cannot export only the landscape for some reason. Then I imported it into Blender, removed the unnecessary parts, export it as an FBX, and finally import it back into Unreal Engine as a mesh. Why? Only then was I able to properly have things separately. But other than that, I think I had this problem due to the way I planned out the map, and ultimately the landscaping tool is pretty solid. Next, we have
The nav mesh.
it's really simple to grasp.
The nav mesh.
Is placed into the scene as a volume and calculates a mesh for navigation. Get it? Nav mesh. It basically is an invisible floor for the AI to move on it. Without it, it doesn't have any information about its environment and therefore doesn't know where it's okay to move. The good thing about it is that it's incredibly easy to implement into your project, gives you customizable parameters and has additional volumes to either add or block paths from the AI. It also uses the A-star algorithm for AI. It's one of the best pathfinding algorithms for getting the shortest path possible to the desired location. I mean, overall, there's not much to say about
The nav mesh.
except that if not customized in certain areas, it does leave errors and bugs, like for example, the enemies not following the player if they're above ground or like falling. And if you stand on an edge of an object or terrain, the enemies will see the player as outside the nav mesh and they won't move. But moving on, I also implemented the Niagara particle system into my game. Thought it could add some atmosphere, but initially I was meant to add muzzle flashes and blood splatters. Look, I'm sure the system is simple, but I haven't quite gotten the hang of it yet. So far, I added snow falling particles to complement my level design. It is also a node-based system like the earlier stuff, uses emitters and GPU acceleration for handling the particle system efficiently. Like I said before, it's got quite a steep learning curve where I couldn't experiment much without help of tutorials and whatnot. And the GPU acceleration of the particle system, while great, could affect performance on lower end machines. Okay, so this project was a big step in my game development journey, and I learned a lot along the way. The features were a bit challenging at first, but I managed to use them. I made snow falling particles, icy landscapes, and AI navigation, which added a lot to the overall feel of the game. That said, there were some challenges. Because I'm still new to this, I struggled to keep up with the deadline, and planning could have been a lot better. Some tools like Niagara had a steep learning curve, so I couldn't experiment with them as much as I wanted. I also ran into the technical problems, like having to use Blender to fix parts of the landscape or dealing with bugs in the nav mesh. These setbacks took a lot of time to figure out and definitely slowed down my progress. Performance was another hurdle I faced. Unreal is great for creating high quality graphics, but that comes at a cost. My game didn't run well on low-end devices, which could be a problem if I wanted more people to play it. While there are ways to improve the performance in Unreal, it takes extra effort and time, which, as I said, I didn't really have anymore. Looking back, I think there's a lot I can do to improve. First, I need to get better at time management. Breaking the project into smaller tasks and tracking my progress with tools like Trello could help me to stay on top of things, but I think the real issue is procrastinating. In the future, I'd like to try out other game engines like Unity. Unity uses C#, which is easier to learn than C++, and it's not as focused on realistic graphics, which fits more with the style of games I want to make. Exploring Unity could give me more options and help me grow as a developer. Overall, even though this project was tough, I'm proud of what I did, and the lessons I learned will help me in the future. So, this project was tough, but worth it. I learned a lot about using Unreal Engine, worked through some challenges here and there, and got a better idea of what goes into making a game. Even though I have a lot to improve on, like managing my time and improving performance, I'm happy with what I made and excited to use what I learned in the future projects, whether that's in Unreal or trying out Unity.